else for joining us today. I appreciate you guys sticking with us. I know we changed the date on this webinar a couple times. We had to accommodate some doctor's appointments, so we appreciate you guys sticking with us. So today we're going to talk about some tips for migrating from classic applications to EPMA and Calculation Manager. So real quickly here, just a brief background on the company. We're a Oracle Gold partner specializing in Hyperion product or Hyperion implementations, specifically Essbase planning, Hyperion financial management, the consolidation tool, FDM, the data integration tool, and DRM. We also do quite a bit of work with ODI, the Oracle Data Integrator tool that is used with these applications quite a bit to load data. We have experience in a number of different verticals. I won't read them off here, but just bear in mind we have worked across a number of different industries. So today we're going to talk about, as I mentioned, converting an application or migrating a number of applications from Classic to EPMA and Calc Manager. And in our particular situation, the case that we ran into several different issues that we had to work around in order to manage. And that one of the first issue that we ran into was a rule set or sequence issue in EAS Business Rules. You could create sequences which are called rule sets in the new Calc Manager, and there are some issues converting those sequences from EAS Business Rules to Calc Manager. The next issue involves using global variables in Calc Manager, and we'll talk a little bit about that. Then the last issue that we ran across involved merging the dimensions into EPMA, and we'll talk a little bit about what those issues were and how we worked around those. And then lastly, we needed a change management process to manage changes during the development, right? Because changes continued to occur in the production applications that we were merging together into EPMA and Calc Manager, and we needed a way to sort of manage those changes as the development was occurring. So we'll talk about that. So just a little bit of a timeline of EPMA and Calculation Manager, just to provide a little bit of context. Right back in 2007, Oracle acquired Hyperion. Shortly after that, EPMA and Calculation Manager were first introduced in System 9. Very kind of almost buggy. I don't want to be too disparaging, but it was a bit clunky and had a lot of issues that needed to be worked around in System 9. Then in 2008, Release 11 came out that had a number of new features, Essbase Studio, including and as well as some enhancements to Calc Manager. Throughout the next several years, Calc Manager, you could either use EAS Business Rules with your planning and Essbase applications that were developed through EPMA or through the workspace, or you could use Calc Manager. So you kind of had an option to either use the new Calc Manager Business Rules or EAS. If you were using one of the modules like Workforce Planning, for example, or something like that, you were forced to use the new Calc Manager up until version 11.121. Version 11.121 was released in 2011, and that was sort of when you were forced into Calc Manager. And then with version 11.122 that came out in 2012, the EAS Business Rules were completely removed, and FDMEE, which we won't talk about here today, but that was sort of the same version when that was released as well. So just to provide a little bit of a timeline, and so we were dealing with a situation, right, where we had a client who had developed an HFM application, 2 planning applications and 3 Essbase applications, 2 ASO and 1 BSO Essbase application, all using EAS Business Rules and all managing their dimensionality individually within each application. So the HFM dimensions were managed within HFM, planning dimensions and planning, or within each of the planning apps, and the same thing within each of the Essbase apps. But there was obviously a lot of crossover in those dimensions. The dimensions were identical, or were intended to be identical across a number of these applications, but because they were managed independently, they weren't necessarily identical or as identical as intended. So we were dealing with a situation where they wanted to then convert everything to EPMA and Calc Manager, have one version of the dimensions in the dimension library where they could manage all their dimensions, and those changes would propagate across all the applications with a single change, and their business rules would all be managed in Calc Manager. So with that, before we get started and going into all these issues, we had a couple of poll questions we wanted to ask. So Melissa, I will hand that back over to you for the poll questions.
Great, so our first poll is, are you currently considering moving to Calc Manager? If you could please just select if you are, if you're not, or if you are unsure or currently using it, just go ahead and click unsure. Okay, we'll give it a couple more seconds for people to vote. Okay. So it looks like most of you guys are either unsure or currently using it. And then we'll go ahead and start our next poll. Which is, are you considering moving to EPMA? Please select if you are, if you're not, or if you're unsure. Okay. Looks like most people are unsure about that as well. Well, luckily you'll get a lot of background information during this webinar, so try to keep it pretty broad. Okay, Chris, those are the polls I had for you today.
Great, thank you. Excellent, well that's great, and yeah, hopefully we can maybe provide a little information to help people make a decision about whether they want to make the move to EPMA and Calculation Manager. So the first issue we ran into, as I mentioned, EAS Business Rules, and for those who recall old planning applications, prior to Calc Manager, Business Rules were managed through the Essbase administration console, and you could manage your business rules there and write your business rules to particular planning applications and that sort of thing. So in EAS Business Rules, a sequence, which is really organizing perhaps a number of business rules to run in order and use the same runtime prompts throughout the sequence of rules that get run. Those sequences could include multiple applications. So I could have a rule from a planning application as my first rule in the sequence. Then my second rule in the sequence could run against an Essbase BSO application. Then my third rule in the sequence could then go and run against the planning application again. So perhaps I've got, I'm moving some data from my planning application to an Essbase BSO application where I want to then run a calculation on the BSO side for performance reasons, and then move the results back into my planning application or something like that. So that's our case here, right? We have a business rule sequence where we have a rule running in our planning application one, then we run a rule in our Essbase app, and then our planning app. So the issue with this is that Calc Manager rule sets can really only include one application. So when I create a rule set in Calc Manager, all of the rules that are included in that rule set have to be from the same application. So they all have to be part of that planning application, or they have to be part of the Essbase application. And then there are some issues there, some limitations in terms of what I can do rule-wise with Essbase apps. So, so that said, we needed a way then to replicate these sequences that made calls to different applications in our source side, or in our current environment or our old environment, and we need to replicate that in the new environment in Calc Manager where we can execute these things. So how are we going to go about doing that? We create a rule set that includes rules that call Maxell scripts for running the calculations on the Essbase app. So there really become three components to the rules or the sequences. You create the rule set, which would sort of mimic the sequence in EAS Business Rules. You create all your rules for the planning application. So these would be essentially the exact same business rules that existed in EAS Business Rules, copied over, migrated over into Calculation Manager and redeployed. So no real changes to those business rules that were specific to the planning application. It's really the rules around the Essbase application that needed to be recreated as calculation script, Essbase server are then called through a Maxell script, which is called from a business rule within Calculation Manager. So kind of a process to replicate the sequence there. So we use an available custom-defined function, a CDF, that's available called this, and I don't know if hopefully you guys can see this, at Calc Manager execute encrypt to Maxell file. So this is a CDF that's available in Calculation Manager that allows us to make a call out to the operating system and execute a Maxell script that exists on the Essbase server. Right, and so in this case, the fix doesn't really matter in this case because you're ultimately going to be executing a separate calc script that's running that exists on the Essbase server. And those are passed as parameters here. So you pass in the name of the Maxell script that you're going to run, and then any runtime prompts that might have existed in the original Essbase business rule. So you pass those in as parameters here, and that's all part of the at Calc Manager, this CDF, this custom-defined function that we use. That's part of Calc Manager. One important note to make here: in our case, all of our runtime prompts used a single member for the runtime prompt, which the CDF manages just fine. However, if you have multi-member selections, if any of your business rules have multi-member selection runtime prompts, this would need to be tested further in order to verify that would work. So the Maxell script then, right, exists on the Essbase server, and in our case, we created the Maxell script with the exact same name as the Calc Manager rules, so that it was easy to understand how they were paired together. And then the Maxell script had these three steps. They each follow the same exact sequence. We set the runtime prompts, passed as a variable, and that runtime prompt is really a substitution variable. And then we execute the Essbase calc script that was created that mimics there's a copy of the Essbase business rule that existed in the old EAS version, right? And so as an example here, we pass in the variable here. We use double quotes in the event of member names that have spaces and that sort of thing. So we have this additional set of quotes around it to manage that potential issue. And this $3, right, is just one of the parameters that we've passed into the Maxell script. So we set this variable to the value that was passed into the Maxell script. We then use that variable to update our substitution variable, or update a substitution variable that would have the same name as the runtime prompt. The only difference is that we put a P underscore on the front of it for as a naming convention. And then we execute our calculation, our Essbase calculation script on the application that we're on the Essbase application. So this then allows us to run in our rule set, allows us to run a business rule against the planning app, then run a business rule that makes a call out to the operating system, that runs a Maxell script, that executes a calculation script on the Essbase app, and then the next step in a rule set would be to execute the rule on the planning application, the next rule on the planning application. The Essbase components, as I said, the original business rules were just simply replicated as calculation scripts with the runtime prompts replaced as substitution variables, and the substitution variables, as I said, we use the P underscore prefixing for easy identification, and again, pairing of the runtime prompt to the substitution variable, so that there's an easy understanding of how those paired. Logs came in handy from time to time as we were doing testing. You can access the logs from the tools job console, and when you get into there, when you get into the job console, you can expand the rule set to see all of the rules that were executed within the rule set. And if you actually click on the run status, you can actually see parameters that might have been passed in to the particular business rule, so you can make sure that your parameters are being passed correctly through each of the steps. And then, of course, there's also logs on the server that are always extremely invaluable when all hope seems lost. The next issue we ran into had to do with global variables in Calc Manager. Within Calc Manager, there's a variable manager, and the variable manager where you create your runtime prompts for your business rules, it doesn't allow for you to create a variable that maps to a custom dimension. So as you can see here, in this case, we're creating a test variable. We have the option of the standard dimension types for a planning application, but we don't have a custom dimension type or a generic dimension type here. So if we want a runtime prompt or a variable for a custom or generic dimension in one of our rules, we needed a way to work around that. Within Calc Manager, there are varying scopes for your variables you can set. So you can have a variable that's global, meaning it applies to all business rules across all applications. You can have application-specific variables, plan type-specific variables, right? So it might be valid just for plan one of the planning application. And then the lowest level of scope for your variables in Calc Manager is the rule scope, meaning the variable is only valid within the scope of the business rule itself and not beyond that. For our scope mapping, all of our global dimensions, obviously for standard dimensions, since we can't create non-standard dimension global variables in Calc Manager. So all of our global variables for our standard dimensions map to global variables in Calc Manager. And then all of our local variables that we had in EAS and our EAS Business Rules mapped to rule scoped variables. And this is essentially the workaround that you can do to create those global variables for the custom dimensions. So the first step is you create a variable using an allowed dimension type, such as entity. It doesn't have to be entity. It could be any dimension you wanted. You then insert that variable into a business rule, then export that business rule. It exports out as an XML file. You then edit that rule in a text editor. So once you export that XML file, you open it up in a text editor, replace the dimension name with the custom dimension name that you want that variable to reference. Then you import the rule back into Calc Manager, and then that custom dimension is available, or the variable for that custom dimension is available. So fairly straightforward workaround in order to get a global variable that references a custom or generic dimension. In addition, on the Essbase side, for Essbase rules, there's no option for global variable as well. But once you've created those global variables, either for standard dimension types or your generic or custom dimension types, you can actually just manually reference them by typing them in your business rule. Easy enough to reference them once they've been created using that workaround on the Essbase side. Easy enough to use them on the Essbase side after the work, creating them using the workaround. Then the last issue that we ran into had to do with the shared dimension library, right? So we're merging all these dimensions together into our shared library. And again, as I mentioned, we had multiple planning applications that had dimensions being managed within each of those planning applications, HFM application, and both ASO and BSO Essbase applications. So we had all these different dimensions that we needed to merge together into the EPMA shared library. And there's one potential issue that you run into with BSO and ASO properties. So if you happen to have ASO and BSO Essbase applications that you want to merge into the EPMA shared library, there are certain properties that overlap within the EPMA shared library. So as you merge these together, you may wind up with conflicts on these properties, and you have to choose one or the other. And I'm going to show a demonstration of this here in just a second, because I think it's a little bit easier to see that way than try to look at screenshots. But before I do that, I want to walk through kind of what the steps were for doing the merge of each dimension. So let's take the account dimension as an example. We chose one of the applications to be our baseline, and in our case, we chose one of the planning applications as our baseline for the account dimension. We then compared that baseline dimension, hierarchies, properties, everything, against all of the other account dimensions from each of the other applications. So we picked one planning application, account dimension. That's our baseline. We then compared that account dimension against the other planning application account dimension. We then compared that account dimension against the HFM account dimension, and then against the ASO and BSO Essbase account dimensions. And as we did that, we identified where there were any differences. And we did this all in Excel. There's some Excel formulas, fairly straightforward, you can create to do these sorts of comparisons to compare things. One thing I will point out that you'll need to make sure, if you have alternate hierarchies in your dimensions, it's a little bit trickier to make sure your shared members are to do that comparison to compare your alternate hierarchies as well. So as I said, we then identified those differences that might exist between our baseline dimension and our other dimensions from all the other applications, and we identified hierarchy differences and property differences. So there might be certain cases where members were in a different order. The members in the account dimension were the same, but they were just in a different order, and so we wanted to note that. And then property differences, maybe there was different data storage in the planning app. There's our baseline, the data storage was never share, but in the second planning app that we were comparing, member data storage was store. So we might have had slightly different data storage across the different applications. So we wanted to, first we did all of these comparisons, identified where any differences might exist, and then went through a rationalization process where we either corrected the difference in the non-baseline or in the baseline potentially, right? If we decided, nope, the planning app 2, the data storage there is actually, we actually want that one, we would go back and change the baseline one and move forward, or we would correct it in the applications that we were merging into the baseline. But again, the one issue we run into is with this ASO and BSO properties, and this is where I'll show you here. So here you can see, looking at an application library, I'm logged into EPMA or into Workspace, and I've logged into EPMA where you can see all these different applications. And I've got a test ASO and a test BSO application here. Right? So one's an ASO, one's a BSO. And if I go actually into my dimension library and I start to look at the dimensions in each of the two applications, right? In this case, they're the exact same dimensions in both applications. But if I look at the properties here in my shared library, and I'm just going to use a member in this entity dimension here as an example. If I come over here and look at my properties, right, I have Essbase ASO and Essbase BSO properties, as well as planning and HF consolidation and other properties that were all being merged together here. But if I look at my Essbase BSO and ASO, if I convert this, let's say in the ASO application, this was set to a minus or an ignore versus a plus. So I've changed it on my BSO, but when I switch to my ASO, it's changed along with it. So this consolidation operator, and the same thing applies for data storage. These two properties are the same for both ASO and BSO within your EPMA dimension properties or member properties. So again, now that I'm on ASO, I'll change this back to plus, save it, and when I switch back to BSO, my consolidation operator is plus again. Same thing, data storage here. I make this never share, save it, go back to ASO, and data storage is never share. Change it to stored data here, and BSO switches back to store data as well. So there were these handful of situations where we had different data storage properties on members or different aggregation operators on members between the ASO and BSO applications. So we had these differences. A lot of them, particularly the consolidation operators, were rationalized, and those were identified as differences that needed to be cleaned up and set to one particular consolidation operator. But for data storage, you definitely can run into situations where, from an ASO perspective, your data storage property is might be different than your BSO data storage property, and so we needed a way to manage that. And the way we did that then is we override the property at the application level. So if I then come and select this guy here, you can see here initially it's inheriting, and that's what these little red arrows here mean. It's inheriting the consolidation and data storage properties from the shared library member. So if for some reason on my ASO application here, I wanted my data storage to actually be never share or something, I can then override it at the application level. So my shared library, it's still store data, but at the application level, it's now never share. And you can see here the little icon means it's been overridden or defined at the application level rather than inherited. Okay. So, and then some of the issues that you might run into with the ASO versus BSO properties that you need to potentially override, things like your hierarchy type, right? Because your stored hierarchies can only have the non-consolidation operator, the tilde operator. Sorry. Only underneath label only members, or so you can only have tilde or plus operators, right? And so I might in BSO I might have some other types of operators that will cause some issues. Same thing with my hierarchy type. You can have either stored or dynamic within ASO, and your dynamic hierarchies can contain any consolidation operators, but stored, right, can only have the plus or the tilde operator. So you might have a stored hierarchy with a minus operator or something in your BSO that you can't have in ASO, and so you need to override that as you consolidate and merge these dimensions into a single library. And then data storage options, kind of again back to the different hierarchy types, but right on the stored hierarchy, you have limitations if a member is label only. So again, you have kind of some of these limitations on ASO and how properties can be set that you might run into some issues there. And then lastly, the change management process. So as I mentioned, during our development, as we were going through this process of merging all these dimensions together, all of these applications were still being used. They were still in production, right? The planning apps and the HFM app and the Essbase apps, the business continued to move on even though we had this work to do. And so they were doing things like adding new members to dimensions and moving some members around and maybe adding new members to alternate hierarchies or creating new alternate hierarchies, maybe updating some properties. So, and those properties might be consolidation operators or data storage or UDAs or all kinds of things like that. So we were tracking all these different properties. So we want to make sure that as those changes are being made, we're identifying those in some way. So we created a process to track and manage those changes. And based on the volume of changes, how you go about doing that, may vary. In their case, the volume of changes was not huge. It was, but it wasn't immaterial either. They were, let's say, making roughly about 10 to 15 changes a month, and across these different change types, So we had a manual change log where they would, for every dimension, they would identify what the change was. They added a new member, they moved a member from this branch to that branch, they updated the data storage property from A to B or whatever. So we had a log in Excel that for each dimension where we would track any changes that they made. Once those changes were applied to the EPMA shared library where we were merging the dimensions, we would then use LCM to take a snapshot of that so that we had some change control on the target side as well for those changes. And so between those two things, we had a fairly reliable change management process where we were able to mimic the changes that were being made in real time in production into this development environment so that testing could occur and be tied out between the production and development environments. So with that, that's the end of what I have. So at this point, we'll open it up for questions if there are any.
If you do have any questions, just go ahead and type them in now at this time, and we'll have Chris answer them for you. I don't see any coming in.